In this video, I will be showing how temperature, concentration, particle size, and the use of a catalyst change the rate of reaction. And the rate of reaction is pretty much the measurement of how many molecules are colliding at a certain time. And that is also known as collision theory, which says that atoms, ions, or molecules that have a high enough kinetic energy and collide during a reaction collide during a reaction can make a new product if they have a high enough kinetic energy or activation energy. So that is what I'll be doing. In this demonstration, I will be dissolving salt in cold water and hot water to show how temperature affects the rate of reaction for any reactant or any reaction. So I'll be dissolving about half a tablespoon of salt in each cup. There's one. Sorry. So if you can tell, the salt is slowly dissolving into cold water because the temperature varies directly with the rate of reaction. So the colder the temperature gets, or the lower it goes, the lower the rate of reaction goes, because the molecules are moving slower, so they're not colliding as much, so there's not as many reactions. And the hot water, I think it's already dissolved, it's dissolving a lot faster, while in the cold water there's still salt in the bottom, because since the temperature varies directly, the warmer the water is, the higher the rate of reaction, because since the temperature is higher, the molecules are moving around faster, so they're colliding more. So they're causing more reactions. In the next demonstration, I will be dissolving sugar cubes and granular sugar in the same temperature of water, but in separate cups, to show how particle size affects the rate of reaction. So first, I'll put one sugar cube in a cup of water, and then I'll put about half a tablespoon again of sugar into a cup of water. So the sugar cube is taking a while, but the granular sugar is already dissolving really fast without me even stirring it, because the granular sugar is not all in one piece like the sugar cube is, so it has a higher surface area. So since there's a higher surface area, there's more room and more molecules that can collide, so there's more collisions, so there's a higher rate of reaction. Whereas this sugar cube does not have as high of a surface area, so it's still taking a while for it to dissolve in the water. So that's how surface area affects the rate of reaction. Okay, for this demonstration, I'm going to show how concentration affects the rate of reaction using vinegar, baking soda, and water. So I'm going to put a half cup of vinegar in each of these cups. But I'm going to dilute this cup with 1/3 cup of water. And then I'm going to put a half teaspoon of baking soda in each cup and compare the reactions. So that reacted pretty fast. Now let's see how the water reacts. So each of them reacted pretty quickly, but if you could tell, the water, since there was more to begin with, it didn't foam up as high. So, because the vinegar was less concentrated, because when it's more concentrated, the molecules are more tightly packed and closely condensed with the baking soda, so they collide more and cause more reactions. But since there was water diluting this cup, the molecules weren't as tightly packed, so they didn't. So for this final reaction, I'm going to show how using a catalyst affects the rate of reaction. So first, I'm going to put 1/2 cup of 3% hydrogen peroxide into this empty soda bottle. Then I'm going to put about half a teaspoon of food coloring in there. And 1 teaspoon of dishwashing detergent, or Dawn, which might stick a little. Okay, now I'm going to put about 1 tablespoon of dry yeast into this cup that has 3 tablespoons of hot water. And then I'm going to pour the yeast mixture into this mixture that I've made in the soda bottle. First I should mix it around in here. Okay. Then I'll put it into the So for this reaction, the catalyst was the food coloring, because as you can see, the catalyst is left over, so it's not actually mixed in with the reactants, and the food coloring is down here and not in the mix. When we mixed the yeast mixture and the mixture that was in the soda bottle, they only were able to react since the food coloring was in the mixture. Because if it wasn't there, they wouldn't have a high enough activation energy, as shown by the this activation energy curve, that if you have a catalyst, the activation energy required with a catalyst is much less than the activation energy required without a catalyst. So, because there was a catalyst in this soda bottle, the reaction occurred, but without a catalyst it wouldn't have happened.